Hi everyone, welcome back to another video in our channel Neural Hacks with Vasant. So in this video, we'll be seeing about how to create your own local LLM. Okay, so we have ChatGPT, right? So we'll be having a similar interface like ChatGPT. You can ask your questions by loading your LLM of your own. So if you don't know, we have already fine-tuned Llama 2 on our own. Even that model should be suitable with this framework. Okay, but unfortunately, I don't have the GPU, enough GPU to load that kind of a heavy model. Okay, so since this is just for teaching purpose, I've just loaded a small model. Okay, but you can also try with some bigger models. I have tried with Flantify Large, it did work. And here I'm gonna show you uh, a coding model. Okay, so there is a version of SantaCoder of 1 billion. Okay, so let me get this. Just give me a minute. I'm just gonna open it. SantaCoder. So here there is SantaCoder 1 billion, right? Thanks to Tabby ML, we have just taken the model from this person or else this organization. Okay, so we'll be using this model and making a disclaimer. We are quantizing it and then we are running it, so we can't expect performance here. Okay, so this is like I said, just for teaching purpose. So yep, I'll first show you what we'll be having as our end result in this video, and then I'll uh, go through the steps for you all to achieve this. Okay, and the setup, we won't be doing it in live, or rather through this video. Okay, because it took a lot of time, but I'll say what you need to do in detail. Okay, so yeah, let's see here. Try let's say def check even odd. Okay, so let's see what it is saying. uh yeah, it is trying to find an answer. So yep, finally it has generated. Okay, so here you can see we can also have chat history, guys. I'll say how it is possible. Okay, when we are going through the setup, I'll show you how. But for a quantized model to run in a very low computational environment, it did okay. Okay, it is good. It was able to generate if n% to equal to 0 written, even n% to not equal to 0 written all. Okay, so now this is fine. What I'm gonna do is I'm gonna close this entirely, and I'll show you how to run this from first. Okay. So, yep. Now what I'll do is I'll show you the VS Code. Okay. So let me stop all of these. This is fine, and this is also fine. Okay. So it will just terminate. First, I'll create a to-do file for you all here. Okay. To-do.txt. Okay. So I'm running this in Windows, but here, if you see, this is the repo. So this usually runs in Linux. Okay. So the best way is to install it via Docker. Okay. So this is a library called Text Generation Inference, which is created by HuggingFace themselves. Okay. So this library provides you an efficient way to inference it. Okay, they have optimized it. So like you can see, right, you have optimized architectures. Flantify is there, Galactica, Llama V2, MPT, Falcon, StarCoder, SantaCoder. Every model is there, and also you can load any other model of your own. You can see right here. Other architectures are supported on best effort based on the basis of using auto model for cos LLM or auto model for seek to seek LM. So any of these generation models can be used. So these are some running scripts, but the main thing to notice is to use GPUs, you need to install NVIDIA Container Toolkit. We also recommend using NVIDIA drivers with CUDA version 11.8 or higher. Okay. So first you need to set up your system with uh, so first you need to set up your system with just a minute. Sorry, I was keeping the wrong screen. Okay. So like I said, here is the text generation inference, and here you are seeing, right? Like they are using a Rust background. Okay. And here are the optimized architectures, and they are supporting other models also, like I said, by using these methods. Okay, so you can also load any of your models if it is in Hugging Face. So, like I said, you need to install NVIDIA Container Toolkit. Okay, but before that, you need to set up NVIDIA CUDA Toolkit. Okay, so for me, I'm using a RTX 3070 Ti. So I'll be supported with NVIDIA, CUDA Toolkit version 11.8. Okay, so that can be installed, and once that is done, you need to install CUDA NN library as well, just to make sure that you are first, like you need to set up your system in such a way that if you run torch.cuda.is underscore available, then it should return. Okay, you can just write import torch and then print to the torch.cuda.is underscore available. I'll show you now. Okay, so the first step would be that. I'll also give you some links on how to install it. Okay, so I'm just calling Python here. Okay, this is WSL, right? I'll call Python here. So I didn't conda activate nh. Sorry, conda activate dummy. Okay, so this is an environment. So if I do Python here, import torch, it will take some time. Okay, torch dot cuda dot is underscore available. If it returns true, then yeah, the first step is ready. Okay, so for this, I'll just write it as ensure cuda is set up in local. Okay, for this, you need to have CUDA toolkit installed. Okay, and then you'll need code nn, and then you'll also need to install Visual Studio Community. Okay, these all needs to be installed. Okay, so that is very important. So if that is done, the next step would be to install this NVIDIA Container Toolkit, because we'll be running everything in Docker. Without Docker also you can do, but the installation will be so hard. Okay, like you'll be having this kind of uh, you need to install Rust. You need to have a protoc zip. Okay, so you need to install protobuf. That is all there, but with Docker it is very simple to execute. So you might think, Vasant, Docker doesn't execute in Windows. That's why we'll be using WSL. Okay, so Windows Subsystem Linux will be using that. So now I'm directly gonna refer you some videos. So I'm directly gonna refer you some videos. Just give me a minute. So here is it. So this is a video I used step WSL2. Okay, so this is a great video. You can have a look onto this. Okay, I'll give this link in the file here. Okay, to set up NVIDIA container toolkit. You can just refer this video. Okay, and if you do that, you will be done with the pre setup, what and all is needed for this text generation inference library. That will be done. Okay, so now after that, what you need to do is you need to open your WSL shell. Okay, and here they have given Falcon 7B instruct, right? Rather than Falcon 7B instruct, we'll be using tabby ml SantaCoder 1b. You can just think like how to get this model name. Whichever model suits your GPU. For example, I have only 8 gigs of GPU VRAM, so I had a very small model. This was even slightly big. Okay, like we had 2.25 GB, and then once I loaded it with quantization, still it took 5 GB. Okay, so be careful when you choose your model. So once that is done, you can just execute here. Then you need to have a volume. Okay, so where the data can be stored, we are giving a directory there also. Once that is also done, like you can see here, um, just give me a minute. So we were executing it from here. Okay, so here we have this command, right? So it is docker run GPUs all SHM size 1G. I've also had this command in VS Code itself. So let's see that now. Okay. So here it is. Here we are running docker, and I'm running sudo command because it requires it. Okay. So without sudo you can't execute in WSL. So sudo docker run GPUs all SHM size 1G, port is 5000. Okay, and we have provided the volume as well, and we are providing the model here. Model ID is model, we have already defined it, and we are providing a value for quantize. Okay, for quantize there is two values, bits and bytes and GPTQ. It uses both of these, and we are going for bits and bytes. Okay, we'll just execute this, and it is asking my password. I'm just entering it. um so it will take some time. Okay, so let's leave that right now, and then after that, for this I'll also provide you the execution here. Text generation inference. Okay, to commands to execute. So we'll be needing a model, right? So model equal to your model. I just keep it as your model here. You can just provide your model. Okay, and then volume you can just have it like this itself, and followed by this. Sorry, you need to install that. run that docker run command. Okay, I'll add sudo here, and you can have any port here. It was defaultly given as 8080 in the GitHub repo, but you can also have your own port. Like for example, I'm running it in 5000. You can also run it in 3000 or 2000. Okay, and if it is required alone, have this. Okay, quantize bits and bytes. Okay, so these are all there. And once this is done, you'll have an execution like this. It will take some time. You might think, like, how long should I wait? It will take some time based on your computation. Okay. So next, we need to execute the chat UI. Okay. This text generation inference is kind of your backend, and chat UI will be your front end. Okay. For chat UI, first you need MongoDB. Okay. MongoDB instance is needed. But if it is not set up also, don't worry. I'm also now going to provide you a command which is available in uh, their repo itself, HuggingFace Chat UI. Okay, for now I'll just have these links as well in your to-do file. Okay, so for installation of MongoDB, right? You can execution of MongoDB. You can just execute this itself. Okay. Let's see this command. How to execute this command. Okay. So I'm just shifting into VS Code now. See guys, I didn't even change anything. I'm adding sudo again. So Mongo Chat UI. I've already executed it. Okay. So you'll I'll get some error like it is already getting executed or something like that, but you won't get anything. Okay, I'm already executing it, so I will get that, but you won't get it. Okay, so once this is done, you're all set to go. Okay, the next step, maybe we'll have these as steps as well. 3, text generation inference setup. 4, chat UI prerequisite MongoDB. Why I'm keeping it like that, I'll show you. Okay, again I'm just gonna copy this and have it here. Okay, this time we'll be setting up chat UI itself in our local. Okay, so we'll have it as 5. Okay, so once that is done, first thing is doing a git clone. Okay, git clone. I'll copy the repo URL. Okay, I hope you all know how to do that. Okay, so git clone this command. Okay, you can just execute it. It will create a folder like this, except to.txt, everything will be there, and you might not also find node modules. Okay, once this is done, next you need to create a file called env.env.local. Okay, so for this, a sample, what and all you would need is you need to give a MongoDB URL. Okay, so here we are running it in 27017 port, right? You saw it previously. Okay, so we are running it in 27017. So you can just have it like this. This is host and this is port number. Host URL and port number with MongoDB as a prefix. Okay, then you need to have a models list. Okay, so I'll just give you this complete uh, thing here. Okay, I'll maybe even provide the .env.local file itself. Okay, so that you might not face any error. what you can do is, now is it running? Yes, now it is running. Okay, so finally you'll be having something like this. Um, we are running it in 5,000 port right now, so we are having it as 5,000 here, and you can have any port here, like 3,000, 2,000, whatever you are executing, you should change here, and you can provide your model parameters here. Okay, so this is your .env.local file. Okay, so that is there. So next step will be to create this .env.local file, and the contents I'll keep it in our GitHub repository. Okay, or even I can .env .local. So guys, I've also provided you the file, like whatever you need to paste there. I've just given you here. Just copy this, create a file called .env.local, and paste the above contents. Okay, so copy this like this itself. The indentation is very important. Okay, so I had some errors regarding that. That's why I'm just directly giving you this file, whatever it is there inside. Okay, so once that is done, paste the above content inside .env .local file. Okay, so once this is done, the next step would be for you to uh, install npm. Okay, so for this, I'll again provide you some commands. Give me a minute. Yes, so npm install. Okay, so from this library only we'll be doing it. Okay, npm node version manager. So we are having a version of 0.39.4. So first you need to execute this command. Okay, since we are in Linux, like this is very easy. So you need to execute this command. I'm just pasting it in our to do file. Okay, via. So this won't be visible in your screen. I'm just sharing you the Chrome right now. Okay, nvm. First code would be this. Second, you need to execute this command. Okay, so that is your second one for you to execute. And then once that is done, you can just execute nvm install node. Okay, so that is here, nvm install node, and that once it is done, you can just check your version, like npm hyphen hyphen version or node hyphen hyphen version. You will be seeing your version of npm and nvm you are using. Sorry, node you are using. Okay, so that will do your npm installation. So once that is done and you have executed your text generation inference backend and mongodb is set, so you can just open a bash or else even your WSL terminal, and you can execute this command. Okay, so npm install and npm run dev. For you, it will take some time because I've installed my npm packages, so it will come faster for me. But for you guys, it will take some time. You need not worry, like it is taking so much time. You need not worry about that. Okay, so now we'll execute this. But before moving into that, I would also like to show you that we are having this text generation inference backend, right? I'll show you how it is now. Okay, we are running it in 5,000, right? So local host 5000 slash docs. Okay, so now you can see it is text generation inference is there here, and you can just use this, like, if you go to slash generate and have some example inputs, you can also provide it from here. Or else if you find like I'm not going to use this chat UI, I'm going to have it in some different front end, such as like maybe Streamlit, then you can do pip install text generation and you can execute this code. Still it will provide you the same output. Okay, so that is text generation inference. Okay, now let's move on with our chat UI. Okay, I'm presenting the VS Code right now. Shell will execute this. Okay, it should take some time. Yep, it's now running. You need not worry about this vulnerabilities and all. Okay, that is fine. So, guys, if you see now, we are having it available in our local host 5173 port. Okay, so I'm now opening it in Chrome. So, yep, now you can see the chat UI has come, right? But the interesting thing, if you note, is that if you click, your history of chat will come, and also you can rename it. Okay, so let's say I've executed even or. Next time if you check, it will be even or, similar to chat GPT. Okay, so yeah, guys, like I said, just experiment with this with your setup. But very important, you need a GPU server. Okay, to have such kind of local chat GPT, you need a GPU server. If you have something like 48 gigs of GPU VRAM, like let's say an A6000, you will be able to execute any big model. Okay, like when you quantize it, you can execute it. So, yep, we have our own local chat LLM. Okay, so I hope you all like this video, guys. So, yep, that's it for this video. And yeah, I almost forgot to tell. Like I told, I'll tell you later. We are having MongoDB just to store this history. Okay, we are having a history here. Like you'll have some history here. Okay, and like you can see, you can change the theme here. You can also do settings. Okay, you can create a new chat and then do something here also. That is also fine. Okay. So yeah, guys, that's it for this video. Try to set up, and if you face any issues, just let me know in the comment section or else even in the Telegram group, and I'll be more than happy to help you out with your setup. Okay, I'll see you all in the next video. Until then, cheers.